recording? Perfect. All right, guys. As I said, my name is Daniel. I'm the track lead here. Our goal at UPE is to basically get everybody into the industry as much as possible, to have a nice community around CS, as we've already discussed earlier. Here are some benefits. Naturally, we've already spent like 40 minutes discussing these, so I'm not going to go over them too long. The next workshop, which was a surprise apparently, is going to be on Friday, April the 2nd. And here's our Discord, if you guys already haven't gotten it, which I'm sure you've already gotten it, right? Let's see, some social media and Discords. Here is my LinkedIn as well as Zach's LinkedIn. Zach, if you guys don't already know, is the UPE code director, and I'm the AI guy. So there's our LinkedIn. If you guys want to connect, I'll probably post them later if anybody wants. Let's get started. So what is artificial intelligence? What is AI? So artificial intelligence is the broad domain that you can very abstractly define as machines that act intelligently. So this in general is the overlap between computer science, linear algebra, and statistics. Now, are you afraid of statistics? Are you afraid of linear algebra? That's okay. It's not.
No.
No?
I want to pass those classes, but no.
Good for you, good for you. I understand that obviously it seems intimidating at first, and for me, it definitely felt intimidating, right? But don't let it intimidate you too much. Machine learning itself doesn't really deal with them into like a very deep amount. So you can kind of get away with that at the beginning. But once you start getting a grasp of machine learning, you'll start understanding the statistics and the algebra. Don't worry about it. So under artificial intelligence, we have a couple broad categories. We have machine learning and we have deep learning. Machine learning, you can kind of think as the broadest field technically today for artificial intelligence. The idea in general is to get patterns from a huge amount of data, right? We're talking like thousands, tens of thousands, millions of input, right? So last semester, for example, I was the team lead for the Spark Dev AI track. And well, we ended up processing what was it, like 2 million Amazon reviews for sentiment analysis, which is natural language processing, right? So it's a huge amount of data. And people like Netflix work on this, a couple other companies like Amazon, etc., right? Then we have deep learning. So deep learning is essentially under the umbrella of machine learning, but it has more to do with neural networks and neurons and essentially complex raw data, right? So pretty much you can think about it as like, if the data you're looking at has too much complexity to it, you can pretty much assume you're going to be doing deep learning. So for example, Tesla is using Tesla is essentially running their own deep learning algorithms and their own deep learning framework, right? Specifically for autonomous vehicles. So within like what, 15 years, 20 years, you guys are going to be able to pretty much rent out your Tesla, right? And use it as like an Uber, and you can get money from it, right? So I think that'd be a really cool idea. Or obviously for the autonomous, right? So we have a couple of applications. So for AI, obviously, if you want to make a Terminator, that's how you would do it, right? Specifically, AI gets confused a lot with AGI, and AGI is artificial general intelligence. In other words, Terminators, Skynets, Ultrons, you name it, right? So AGI is more the umbrella term for kind of, you could think of it as like the goal of artificial intelligence, to eventually have a really sophisticated intelligence that we have made to help humanity, hopefully, right? So that's AI in a very broad sense, right? Then we have deep learning, which has, we're going to see in the next slide, some really cool stuff, right? So we have, for example, generative adversarial networks. We're going to go over that in a second. And then we have machine learning for virtual assistants, etc. And remember, deep learning is under the umbrella of machine learning. By the way, if you guys have any questions at all, feel free to ask me at any time. Yeah, just feel free to ask. Don't feel bad for interrupting or anything. I am an open book. Not too many questions, but yeah, let's do this. GANs. we have generative adversarial network. So this is a type of deep learning network, right? So these networks essentially have two neural networks at the same time. And we're going to go over those a little bit later. So basically, you have some generating data and you have some classifying data. They basically fight each other to see who's right. And in that fight, in that battle, they both improve gradually. It's really cool. To me, it's one of the cooler networks for sure. What's cool about these is that they create data that you've never seen before, right? So for example, this person does not exist. Let's check out this website, right? So this website uses generative adversarial networks, and every single time, can you guys see the website, by the way? Somebody please let me know.
Yep, we see it.
Yeah, we can see it.
See it? Awesome. So for example, this website, every time we refresh the page, it's a face of somebody that doesn't exist. None of these people exist. They were completely generated by the GAN, right? Super cool stuff. And obviously the realism here is insane, right? Like I certainly can't tell the difference between this and a real picture, right? And just over like 5 years ago, it was much worse. Like it was like 4080p quality, right? This is 1080p, which is crazy, right? So, oh, Zach, I'm sorry. So let's go back to the slides before Zach gets any more embarrassed. All right, cool. So next we have machine learning examples such as Series and the Google Homes of the world, right? I was just checking if it activated. I was really hoping it wouldn't. We're good. So basically, for example, these virtual assistants just hear your sound waves and your frequency. They change it into understandable data. And then they know what to do with it. It's really simple, right? Well, abstractly, it's very simple, right? Specifically, this is in the domain of natural language processing. And that's simply the action of taking language, whether written, whether typed, whether spoken, and using it to perform certain actions, right? So let's get into some nitty-gritty stuff. What are some technologies that we're going to be looking at? We're going to be looking at things like TensorFlow, which is owned by Google, deployed by Google. We have Keras, which is essentially like a really good extension for TensorFlow. We have PyTorch, which is like the competitor for TensorFlow. It's awesome. It's made by Facebook Labs. Really good framework for AI, my personal preference, although some will argue with me on that. And we have scikit-learn, which is another great library. All right. First things first, what language are we going to be coding in? Python. Python is the de facto language for artificial intelligence for data science, machine learning today. It's probably one of the easiest languages to learn, which is definitely a big plus, right? So getting into AI without knowing any CS is, I mean, obviously the AI part is you're gonna have to take some time, but at least the coding is not gonna be difficult. Python is very easy to understand. It's very close to human language. So it's worth giving a shot, right? And as you guys will see later, you don't need crazy NVIDIA RTX 3080s to be able to run these deep learning models, as we're gonna see a little bit later, right? Yeah, Python is just amazing. It's really good. It's very open source. There's a lot of libraries for it, and it has a high level of abstraction, meaning it's very easy to understand, basically, right? Now, we're gonna be going over some very good to know libraries that are used very commonly, right? Specifically for Python in relation to data science, in other words, machine learning, right? So we have Python library matplotlib. This one's really good. It's basically used for showing you graphs, modeling data, extremely commonly used. And when you're working in Jupyter Notebooks, which we will also go over later, it's extremely helpful for showing you how the progress of what you're working on is going. Cool. Let's see some questions real quick. So let's see. So is Python only used for AI or machine learning? It's not the only one. So for example, there is a library that I worked on called Stanford Core NLP. And if I'm not mistaken, that one is actually written in Java. So Python is not the only contender in this field, but it is far ahead of the competition. And it happening to be the easiest, I would say one of the easiest, if not the easiest languages to learn. It's a great language to use, right? So do you need Cyberpunk 2077 on max settings for this to run? Well, let me put it this way. You would need 10 GPUs in order to run 10 GPUs that can run Cyberpunk on max settings. You would need about 10 of those. So let's say 10 RTX 3070s to run some deep learning models well. So yeah, this is pretty crazy stuff. Let me put it this way. You need the GPUs you need are so heavy that Google made their own versions of GPUs for AI called TPUs. In other words, tensor processing units, right? Yeah, so pretty cool stuff. Let's see, where was I? All right, next slide. Numpy. So Numpy is basically where your linear algebra is going to be coming in from, right? So it's really good for arrays, vectors, matrices, which, I mean, they're defined in different areas, but they're almost the same things, right? It's basically really good for applying some of the heavier mathematical stuff in AI. And again, today's workshop, I'm going to be showing you, actually at the very end, I'm going to be showing you an actual running project, right? And you guys will actually be able to run this on your own computers as well. So it'll be pretty cool. We're going to check that out in a bit. Pandas. Pandas is another very commonly used library. It is essentially for data manipulation and analysis. In other words, you can think of it like the Excel or the Google Sheets of data science, kind of. It's basically used to organize and to label the data that you're working with, and it's extremely useful, right? Now, let's go over some of the cooler ones. We got TensorFlow, Google's baby, and then a fantastic open source machine learning library. If you guys know about Google Collab, which we're going to be going over, I'm actually going to go over now. Google Collab is basically a way to run things like TensorFlow, like PyTorch, like Keras, right? Like these other libraries, as kind of like Google Docs. In other words, you can just log into Google, you can use Google Colab free of charge, and you can use their servers, their hardware to run some of these really intensive programs, right? In other words, you don't need an amazing GPU or CPU in order to do these amazing processes, right? So TensorFlow does some of the heavy lifting algorithmically, right? So some of the harder stuff is already done in TensorFlow, and it's written in Python and C++. On top of TensorFlow, we have Keras. Keras is basically a high-level API interface for TensorFlow. So it basically works on top of TensorFlow. It's a really good way to abstract some of what you're working on, and it basically makes using machine learning much easier. It makes some of the generalized models much more streamlined. In other words, it makes it easier to run a lot of these programs because you need to use much less line of codes. It's awesome. Also involved using neural networks, right? Then we have PyTorch. PyTorch is amazing. It's again developed by Facebook's research labs. It's basically another TensorFlow, kind of. The main difference is that you can say TensorFlow is basically harder to deploy. Sorry, PyTorch is harder to deploy, but easier to debug. And when you're working on machine learning and deep learning, that's a really big plus, right? So we have scikit-learn. It's built on top of Numpy, SciPy, and Matplotlib. It kind of gets them to work together really well and adds extra features. As I mentioned already earlier, it works on top, so it just adds features. It's a fantastic library if you're doing some basic machine learning like gradient descent. Fantastic library. We're not going to be using it today, but it's really good to look into it. And besides all these libraries I'm mentioning, by the way, there's this website called Kaggle, which you guys should definitely check out if you're interested in this stuff. Kaggle is basically the leak code for data science, in other words, machine learning, right? So there's a bunch of competitions that happen there all the time. And sometimes those competitions have a lot of money. So for example, there is a competition I just saw, I think yesterday or today, that is basically a competition to see who can create the better computer vision classification model to determine, what was it? So basically your input for that case would be skeletons, right? It would be x-rays. And you would have to determine where there are inconsistencies using your machine learning model. If you win that competition, the total prize is $20,000, but the prize for the whole competition is $50,000. In other words, if you win that competition, you get $20,000. So it's really cool stuff. And honestly, like that's an amazing tool for doctors, right? Like they can immediately determine where weird growths are happening, right? It's amazing. We're now going to be going over some neural networks. And again, if you guys want me to say anything again, if you guys want me to rephrase something or any questions, feel free to ask. Don't feel bad for interrupting, okay? So I'm going to go over this very briefly, very abstractly. Basically, neural networks have their input layers, their hidden layers, and their output layers. Input layers are simply whatever data you're feeding, right? So they could be images, they could be numbers, they could be sound waves, right? They could be a million things. Once you process them through your input layer, you're going to want to put them through some hidden layers. The hidden layers are basically where your machine learning model, where your AI project is going to determine what you want out of it. So in other words, like if, let's say we have an image of a cat going through here, right, as the input, then your model is going to say, hey, this has some features, so like maybe like pointy ears, for example, for cats. Let's put it through this specific neuron. Okay, this neuron is basically a function. In other words, like you can kind of think of it like a mathematical function. It does some processing. And at the very end, you have your output. In other words, for example, with cats and dogs, oh, this is a cat, this is a dog. Not super hard. The lines represent weights. In other words, how important this is to process, right? And yeah, that's pretty much it. I just taught you neural networks very, very basically, right? It's not super hard to understand. And if you guys want to look into it, I highly recommend it, right? Let's look at some code, some very cool code. And like I said, later on, I'm going to be sharing the link to this Google Colab. I'm going to be showing you how to do everything so you guys can run this for yourselves. All right. If you guys have any questions, please feel free to ask / let me know. Actually, I'm just going to go into the one I already had set up, if I'm not mistaken. Let me see. Perfect. Let's reconnect here and we're good to go. Perfect. So this is a file that I received from Kaggle. So it's a guy that did this amazing project. This project is actually relatively old. So believe it or not, this has improved a lot over the years, right? So, and this is not super hard to understand, which is why I chose it, right? So let's do this. Before I get into it, actually, real quick, Google Colab again is free. All you have to do is look it up and you will go to their landing page and there they will show you how to basically like get Google Colab, right? Once you have it, all you need is IPYNB files. In other words, Jupyter Notebook files. So Jupyter Notebook is basically a virtual environment that is hosted in the cloud in this case because of Google Colab, right? And basically you can import, you can download all of these things like Numpy, like Pandas, like Keras in the cloud. You don't need to install it on your own machine. You don't need to use your own machine at all. All you need is an internet connection. That's it, right? And you can use Google's own RAM, their own disk space, and their own CPUs plus GPUs. Or if you really want, TPUs, right? AI-specific GPUs. So let's go over this a little bit. So when you're looking at an AI project, you really need, probably the most important thing you need is good data. Now, a couple of you might ask me, what is good data? That's a very hard question to answer, right? Basically, good data is the data that is most peer-reviewed by experts. It's ones that it's pretty much the ones that are most peer-reviewed by experts, period. It's the most popular data sets. Like there's a really popular data set called the MNIST data set. Every data scientist knows about it. It's extremely popular. It's a great way to start with machine learning. And in this case, we're going to be using a Kaggle competitions data. So let me show you guys real quick what that looks like. So we're basically. Hello, do you have a question?
The time mapping of United States, right?
Say it again. Can you say that again, please? No? Okay.
I think they were just unmuted.
Oh, muted, but yeah. So basically, in this project, we're going to be looking at cats versus dogs. So basically what we have is 12,000 images of cats and dogs for training and a couple others for testing. So when you're looking at a machine learning project, you have, I would say, 3 to 4 fundamental steps. Pretty much every project has to go through this, right? You have obtaining the data, which is the most important. You need good data. You cannot have a good machine learning project without good data or verifiable data or a huge amount of data. You need pretty much all 3 of those things, right? You need to pre-process that data. In other words, turn that data into a way that your program will understand. It has to be processed, pre-processed, right? You have the actual model, which is your machine learning model, right? Which processes that data. And then you have your verification, you have your validation, which in other words is how well did my model actually do? And in that case, we go over loss and we go over accuracy, which don't worry, I'll get to that later. So Jupyter Notebooks. Do you guys see how there's blocks of code here? This is how Jupyter Notebooks is. So Jupyter Notebooks are essentially files that can run blocks of code, in this case Python, right? And just stop there. So if I wanted to run all these imports without doing the rest of the program, I can. I would just click here and boom, done. That's simple, okay? Because again, we're using all of Google's technology, all of their hardware, right? So basically what we're doing here in this block is simply importing Numpy, Pandas, Keras for images specifically, because that's what we're working with, right? We're also installing some sklearn. You don't have to necessarily worry about, I don't want to get too into it for today's workshop. Obviously, you guys are just learning about this. But if you guys want to learn about the documentation or how these functions work, again, I'm going to send this link out so you guys can check it out for yourselves and run it for yourself, right? So let's see. All right. So we're going to prepare the training data. What does that mean? In this case, because we're using Keras and it already understands how to process images, we don't need to do a lot of pre-processing on our end. In this case, all we need to do really is just make some data frames. We're going to be doing that with Pandas, right? So as you guys saw, we defined Pandas as PD. So we have PD.dataframe. And as I mentioned earlier, data frames are basically a way of organizing this data and labeling it. So we're simply going to be having the file names and the categories. Okay, simple enough. This block of code is basically for organizing the data, right? This is for initializing the head of the data frame and the tail of the data frame. If you guys want to check into that, please do. And here we simply have a graph showing us, okay, we have this many cats and this many dogs in total in the data, right? So basically the more, if you want to help your model, you basically want to label certain things without telling it. So this is a cat, this is a dog, this is a cat, this is a dog. So then later you can double verify. You can basically say, okay, was my model correct here? Yes. Was my model correct here? No. Okay, it's not as accurate as we want it to be. Okay. Here's a sample image. Okay, we have this cute little cat here. And if you guys don't believe me, and that this is actually a cat from our data set, if I click here, it should give us another random cat or dog. There you go, another dog and another dog. Cool? So I'm not BSing this, I swear. All right. Here we're basically going over some of the layers of the model. You don't have to worry about this, you can check it out later. Basically, as normal, we have the input layer, we have the essentially abstractly the neurons that we're working with, and we have our output, right? We have the probability that it is either this or this. Speaking of probability, basically you can think of a lot of machine learning and deep learning as computer science and linear algebra with, again, the injection of statistics. So with probability, it's usually naive Bayes probability. Okay, so if you guys want to look into that mathematical concept, feel free to. Basically, at the end, the actual output is, okay, there's like an 80% chance this is a dog, so we're calling it a dog. Okay, and the more you train your model, the more accurate it gets. Hopefully, right? More accurate and the less loss. Yes, I will be dropping the Collab link 100%. I will be dropping the Collab link. Yeah, I'll be dropping the Collab link, as well as the, I'll try to also drop the files. The files are pretty big, but I'll see if I can do it through Discord, okay? Specifically the data files. So let's see. Yeah, I got you, fam, don't worry. So let's see. All right. This is basically our model, right? This is just building the model. If this looks intimidating, don't let it intimidate you. All this is essentially using Keras models specifically for images, right? So again, this is a pretty standardized practice at this point specifically with images. This is simply using some functions and some methods within Keras. Not too crazy. Thank you for coming, Victoria. I really appreciate it. No problem. Don't worry. I'm very intimidating and interesting. Don't worry. This is simply using functions. This is not as bad as it seems. Okay. We're going to be doing some callbacks and overfitting. So conceptually, overfitting is a common problem in machine learning. Overfitting is essentially the problem where your data isn't really as good as it should be. So if your data isn't as good as it should be, you basically want to reduce overfitting or underfitting as much as possible. In other words, you want to basically modify the data to take out things like extreme outliers, such as in the case of sentiment analysis, it's removing thes, buts, ors, because those don't matter for conveying emotion, etc. So we're also, okay, another really important thing is learning rate. Remember, you are not telling the model, hey, this is a cat, this is a dog. You're letting it find out for itself. So you control its learning, right? But you don't control how it knows what it knows. Does that make sense? So for example, this is the concept of soft coding versus hard coding. When you make a regular program, so let's say, for example, here at the beginning at the imports. When you have a regular program, you're saying, I want you to import this. I want you to do this. I want you to do this directly. Okay. You define the rules. With soft coding, which is essentially machine learning, right? You're saying, I want you to learn in this direction, but how you know what you know is up to you. And this actually is, so basically, if you ask extreme professionals in artificial intelligence, when you ask them, how does the model know what it knows? They'll be like, right. That's based on extremely complex features that the model itself finds out. So again, I'll be dropping the Google Colab link so you guys can run this for yourself. And if you guys want to run this, basically all you have to do is, first off, let me go over here. First off, you're going to want to go over to the files and put in the data. So in this case, test one and train one, which I will be dropping later. And you want to define the path to those files. Okay, that's all you got to do. That's all you guys have to do on your own part. Okay, download these files, which I will be dropping later, and putting in the path, and it should work for you. Okay, this is the training generator. Let's see, very interesting. Man did computer, not vice versa. Yeah. So let's see. Yeah, this is a training generator. In other words, you can kind of think of it as like, this is basically running, okay, so here is an image, process the image, give us an answer. You can kind of think of this as like a declaration of intent, right? And over here, let's see, where was it? Right. This is our generator at work, and this is kind of how we organize our images. So this is like, if I'm not mistaken, this is pixels by pixels. And what it basically does is get each image, looks at it through different angles, and the model itself determines which is the best one for classification. In other words, for determining cat versus dog. Okay. So as you guys remember from the beginning, I mentioned we have to pre-process our data. We have to create the model, which is essentially what we've done here, right? And then lastly, we actually have to fit the model. In other words, compile the model. This is where the actual deep learning occurs, right? Because we're using neural networks. So basically, if I tried running this, it could go up to 50 epochs. In other words, it'll take a long time to run. So for example, epoch 1 out of 3. So this epoch, let me go over epochs. Epoch is basically saying the program, the model, is running through all of your inputs. In other words, all the cats and dogs images once, right? So every epoch is saying, okay, I went through all the inputs one time, or in the case of the second epoch, I've done it a second time, right? But we don't run them the same time. We run them randomly. So the first time, the first image might be of a cat. The second time, it might be of a dog. You don't want to run the same data in the same order because that's an invalid way of learning. You're trying to make it learn cats versus dogs, not the order of cats versus dogs. Does that make sense? So I could actually try running this right now, and it wouldn't take too long, but again, you have to run this on your own. And this variable right here, this constant, you can define if you wanted to either run 3 epochs, meaning a model that's trained very little, or 50 for a very accurate model. I'm going to show you guys the output of that model in a second. You want to save your model, obviously. This is sometimes called pickling, if you guys are familiar with that term. This is basically saying, okay, I want to save the model so that I can process that trained model whenever I want, right? You don't want to constantly train this. So let me give you an example. I tried running this this file yesterday, okay? I tried running it for 50 epochs. In other words, I tried running the whole thing 50 times, right? For all the inputs, 50 randomly generated times. It would have taken me 2 days. It would have taken me 2 days to process all those images 50 times for the model. Okay, like 48 hours. So you want to optimize your models as much as possible. Machine learning takes time. Deep learning takes more time, right? Training totally depends on how you've optimized your model and how much data there is. Okay, you want to make it as short as possible. And a cool feature is that you can define how you run them. So if you go to here to change runtime, you can either have a GPU, a none, which is in other words just CPU, or a TPU. In this case, we're definitely going to be needing a GPU, right, to run this as quickly as possible. If you want to do just 3 epochs, that'll only cost you 3 minutes. So you guys don't have to wait 2 days to run your files, okay? In today's case, I ran it to 3 epochs, so it won't be as accurate as we want it to be, but that's okay. I'm just showing you guys how to do this cool stuff anyway, right? All right, here we're just preparing the data we want to output and the testing generator. So when you have a ton of data, you always want to save like 10% of it, 5% of it for testing. In other words, did my model actually learn, or is it just making stuff up, right? So did it learn some other way that it shouldn't have, or is it actually working? You should always save a lot of, like again, 10% to 5% of the data for testing purposes, okay? And here we actually have the predictions, right? So at the very end, after seeing the visualizations of some results through some graphs, all this is doing right here is simply formatting and showing how we want to output the data that we found. And here we go, guys. So if we go up a little bit, we'll see that here in the data frame, right, we're defining if it's a dog, then it's 1. Okay, if it's a cat, then it's 0. And this is how it will be labeled in the actual images. So we go down here. Let's see. This is a dog, right? Boom, 1. So that's correct, right? Because again, dog is 1, cat is 0. If we look at this cat, oh, it's 1. That's not right. So it's not as accurate as we want it to be again, because we only ran 3 epochs. Here we have a dog, 1. That's correct. Another dog, 1, and cat, 0. So it's actually not bad, right? Let's see if there's another cat. Cat, 0. Perfect. Cat, 0, 0. Boom. You have just ran and completed a full deep learning neural network using convolutional neural networks specifically, and it works for identifying cats versus dogs. You're welcome. And you didn't even have to use your own computer to do it. So real quick, I'm gonna go over loss and accuracy. So basically, if you want, okay, loss and accuracy are important concepts to understand. So loss, you pretty much want to have in every deep neural network, right? So let me see if I can find it up here. Perfect, right here. So during the first epoch, it ran through all of the images that we wanted, right? It took 124 seconds, and the loss is 0.9946. You want the loss to be as little as possible. Loss simply means how wrong were we when we were wrong. So in other words, if it's a cat and not a dog, how wrong were we, right? Numerically, that's what loss is. Accuracy is how many times we were wrong. So they're important to understand together, right? If you have a really high accuracy and a really low loss, that means you were wrong, you were almost never wrong. And when you were wrong, you weren't wrong by much. Cool? So as you can see, the more epochs, the less we have loss, and the more we have of accuracy. You give it a ton of epochs, it'll go up to, I think this model specifically goes up to 98% accuracy, which is really high. Like an 88% accuracy model is really good. And we have loss of 0.51. Or sorry, yeah, we have loss of 0.51, which means when we were wrong, we weren't super wrong. We were only a little wrong, right? So there you go. And I think I am pretty much good on time, guys. There you go. You guys have just gone through an introductory workshop for AI machine learning, and now you know how to classify between cats and dogs. Does anybody have any questions? I know there's probably a ton, and I'm sorry if I went too fast or I didn't articulate myself as well as I wish I could have. If you guys have any questions, just let me know. If you want me to rephrase anything, just let me know. But that's it, guys. Thank you guys so much for coming.